How hard could it be to make a plastic fork from scratch? It costs basically nothing. You use it for 5 minutes. It bends if your pasta is too confident. So it must be simple, right? Okay, step 1, get plastic. And that's where the whole plan dies. Because plastic doesn't just appear in a little white bin behind a restaurant. It begins with oil, giant machines, food safety rules, and a business model that only makes sense when you produce these things by the millions. All of that for something you throw away with your leftover coleslaw. So let's look at 5 everyday objects Americans barely think about. A plastic fork, a soda can, a pencil, a Big Mac box, and a toaster. And I promise, after this, at least one boring object in your house is going to start looking suspicious. A plastic fork is supposed to be trash? That sounds harsh, but it's true. It is designed to be used once, maybe twice if you're the type of person who rinses takeout utensils and then disappears from your life forever. But designing something disposable is weirdly hard. It has to be cheap enough that a restaurant can give it away, strong enough to stab a piece of chicken without snapping, smooth so it doesn't cut your mouth, clean enough to touch food. And every single one has to come out identical, millions at a time. And before any of that magic happens, you need the material. Most plastic forks start as petroleum or natural gas, turned into tiny resin pellets. Those pellets get dried, melted, and slammed into a steel mold inside a massive injection molding machine. And that part is more delicate than it sounds. The plastic has to race into those super thin tines before it cools too much. Pressure wrong, mold doesn't fill, temperature off, the fork warps. And if the design is off, congratulations, you've created a fork that loses a fight with mac and cheese, which is honestly a humiliating way for an object to go out. And the mold is where the economics get ridiculous. The steel mold for these cheap forks can cost tens of thousands, sometimes over $100,000 for high volume ones. That sounds insane, until you make 10 million forks and spread that cost across every single one. Suddenly, each fork costs basically nothing. One fork would be ridiculously expensive. 10 million? Pocket change. But if even the flimsiest plastic fork needs oil chemistry, precision tooling, and mass production to exist, what about something that looks even more ordinary, like a soda can? A soda can is so thin, it almost feels like a prank. Seriously, the wall is only about 0.1 millimeters thick, thinner than a human hair. But when it's full, it can be strong enough to support a person's weight as long as the pressure comes straight down. Why? Because the liquid inside is pushing back, turning the whole can into a tiny pressure vessel dressed up as a beverage. It's not strong like a brick. It's strong because shape, material, and pressure are all working together. And the shape? Not random. A sphere would use less metal, but nobody wants a vending machine full of rolling aluminum balls. A cube would pack nicely, but the corners would be weak, and drinking from it would feel like sipping Mountain Dew out of a filing cabinet. So we get the cylinder, the least bad answer to a million problems at once. Then there's the manufacturing. A flat disc of aluminum gets punched into a cup, stretched taller, shaped at the bottom, trimmed, washed, coated, printed, filled, and sealed at a speed that looks fake when you see it on video. Factories don't really make cans one at a time, they unleash them. And the inside has a secret too. Many drinks are acidic, so the aluminum needs a thin polymer lining. Without it, the soda and the metal would start reacting. Yeah, your Coke needs chemistry just to stay friends with its own can. Even the pull tab is a tiny engineering trap. It has to survive shipping, stacking, vibration, heat, cold, and pressure changes. But when your thumb catches it, it has to open with that perfect little crack. Too weak, and pallets of soda become a sticky warehouse disaster. Too strong, and every lunch break becomes a thumb injury lawsuit waiting to happen. So that satisfying sound? Decades of levers and scoring behaving exactly as planned. Now, cans at least feel industrial. You can look at one and believe a factory made it. But a pencil? A pencil feels like something a guy in the woods could make after watching 2 YouTube tutorials. That is optimistic. A pencil looks almost primitive, right? Wood outside, dark stuff inside, pink eraser, done. But the pencil is really a history of materials and politics squeezed into something you lose before math class. First, the lead is not lead. It is graphite mixed with clay. More clay makes the pencil harder and lighter. More graphite makes it softer and darker. That sounds like a fun fact from a museum placard, but historically, it mattered a lot. The best graphite came from Borrowdale, England. During the Napoleonic Wars, if your country needed pencils for maps, engineering drawings, or military plans, that graphite was straight up strategic material. So what do you do when your rival controls the good stuff? You change the recipe. In 1795, Nicolas Jacques Conté, a French scientist in Napoleon's army, figured out how to grind lower quality graphite, mix it with clay, shape it into rods, and fire it in a kiln. Suddenly you could control hardness and stop depending on one mine. That method is still how every pencil on Earth is made today. And I don't know about you, but I never questioned why pencils are hexagonal. I just figured someone thought it looked pencil-y. Nope, that shape stops it from rolling off your desk. It gives your fingers flat edges to grip, and factories can cut more of them from the same piece of wood. Even that tiny decision is pulling serious weight. Then there's the rest of the engineering. The wood has to sharpen without splintering. The graphite core slides perfectly into grooves. The glue holds for decades. The paint coats evenly. The metal ferrule crimps the eraser without crushing everything. And yeah, that pink eraser has its own rubber and pumice chemistry going on. After all that precision, your pencil ends up in a junk drawer next to a dead battery and 3 Taco Bell sauce packets. That, apparently, is the life cycle of human civilization. Pencils survived. They adapted. They became so reliable we stopped seeing them as technology. Now let's talk about an object that had the opposite problem. It worked beautifully, and people still turned against it. The old foam Big Mac box was, from a fast food point of view, kind of genius. Not beautiful. Nobody is staring at a beige foam clamshell and whispering, "Design masterpiece." But operationally, it solved real problems. Fast food is a game of seconds. Save 5 seconds on one burger, whatever. Save 5 seconds across thousands of restaurants, every single lunch rush, that's millions of dollars. The foam kept the burger warm, protected it from getting smashed in the bag, stacked perfectly, and closed in one quick motion. For McDonald's, that was gold. Then the public mood changed. People started seeing that foam and thinking landfill forever. Environmental groups pushed. Customers didn't want packaging that outlived the food by decades. Here's the brutal part. The box still did its job perfectly. It won the engineering battle and lost the cultural war. We've seen this happen again and again. Plastic straws went from convenience to villain. A product can work flawlessly and still become unacceptable because people no longer want to be associated with what it stands for. So we've got a disposable fork, a pressure-engineered can, a pencil shaped by war and scarcity, and a burger box defeated by public opinion. Now let's end with the object everyone thinks they understand: the toaster. A toaster is a controlled electrical fire that we allow on the kitchen counter. That sentence should feel stranger than it does, because we're so used to it. Bread goes down, lever clicks, toast pops up, nobody screams. Usually, but the toaster's real problem is not bread. It's us. Inside, the heating wire is often nichrome because it can get extremely hot without melting immediately. The whole thing has to aim that heat at the bread, not your cabinets, your hand, or the pile of crumbs turning into dry kindling underneath. And people do not treat toasters gently. We shovel frozen waffles, pastries with icing, and yes, some brave citizen will eventually stick a knife in there, even though every warning label is begging them not to. So the toaster needs insulation, springs, latches, timing controls, and safety testing. Not because toast is complicated, but because humans are. That's the real design challenge. The toaster has to make a dangerous process boring enough for a half-awake person to use at 7:12 in the morning. And yes, someone will always say, why not just toast bread in a pan? Sure, you can. You can also wash all your clothes by hand in a river for character development, but I don't see many people doing that. That is American convenience culture in one appliance. Not can this be done, but can this be done with one button every morning for years by people who have not had coffee yet? That is a much harder problem. So, yeah, cheap objects are weird. A plastic fork starts with oil fields and precision molds. A soda can is a tiny pressure vessel pretending to be casual. A pencil carries centuries of materials science and wartime invention. A burger box can win the engineering game and still lose to culture, and a toaster is basically a safety-tested electrical fire we trust before coffee. Here's the trick. By the time something reaches your hand, all the hard parts have been made invisible. The refineries, the molds, the factory lines, the shipping routes. You just see the final object. And if it's cheap enough, we assume it must have been easy to make. But cheap doesn't mean easy. It means the hard part happened somewhere else. So here's my question. What everyday object in your life do you think is secretly way more complicated than it looks? Drop it in the comments, because I guarantee there's something in your kitchen, your car, your backpack, or that junk drawer that looks boring until you start asking where it really came from. If you enjoyed this, hit like, subscribe, and I'll see you in the next one.